This is a rundown of the thermal integration Node-HIU control system. This is a monitoring platform and commissioning system for heat interface units fitted on a heat network. If we start by going to the menu and selecting the dashboard. The dashboard gives us an overview of what's going on the development with second by second accuracy. We have a panel that gives us a view of the system health, broken down into alarms and warnings. So these are things that require urgent attention and warnings which should be attended to fairly soon before they turn into bigger problems. We have a link to historical data so we can look back over what's gone on in the past. We also have a performance panel. Now this panel gives us an overview of how efficient the network is running at the HIU level. So we have a current VART which is showing the average return temperature, the volume weighed average return temperature from the heat interface units going on at this moment. This is summed over time to give us our running VART. So this is the VART since the system has been turned on. So the overall VART on this heat network is 27.6 degrees C. And this can be seen here over on the right where they're graphed up. We also have the load on the network. So this is in litres per minute. It is broken down into domestic hot water load and central heating load. And again, this is shown on a graph on the right. If we wanted to see, for example, the load on the network over the whole day, we can have a look at the historical data. Now I'm going to tick the flow for domestic hot water and the flow for central heating. In a few seconds it will generate the graph. So what we have here are the loads in litres per minute over today. Now if I can zoom in, we can see exactly how the load has varied over the time, over the day. So we can see the central heating loads going up and down, and we can see some spikes where hot water has been drawn off. This is very useful for analysing events that have gone on in the past. We can page through the data day by day, so I can go back and look at yesterday's figures, and we can also look at it at up to a whole week combined onto one graph. Returning to our dashboard screen, if we now switch to the commissioning screen. Now the commissioning screen gives us a snapshot of every single heat interface unit on the development. So on this particular development we have roughly 50 heat interface units. The table gives us various information about the HIUs themselves, various readings coming back from the heat interface units, and it gives us operational data. It also allows us to look at the settings. So, starting with the system data, we have an identification for the property for the heat interface unit. We have a last contact which tells us how long ago the particular HIU sent out data. We have firmware versions, the state the heat interface unit is in, how long any errors have been running, and a power up counter which tells us how many times the HIU has been turned on and off. We have, under the settings, we have the hot water set point. We have a boost flow, which is how quickly the HIU will flush primary pipework when it's cold. This is in order to speed up hot water delivery. We have a keep warm mode, which describes how the unit should keep itself on. We have a keep warm temperature. The keep warm time here is set to 60 minutes, telling us that after a tap has been used, this particular HIU will keep itself warm for 60 minutes and then go cold. We have a Legionella cycle, how the system calculates differential pressure, central heating set point, central heating return temperature limit, whether the return temperature limit is enabled. We have a pump timer for central heating, so this is a pump overrun feature, and we have a central heating enable and an HIU enable or run. These can be used for remote control of central heating or for turning on and off the HIU for functions such as prepay. Under the operational heading, we have the current loads on the network. We have the central heating pressure in each property. This first one is showing a warning. The warnings come on when the pressure drops below 1.5 bar, and this will turn into an alarm when the system reaches 1 bar. We have the estimated differential pressure on the heat network, and we have data concerning the last domestic hot water use. If we go to readings, we can see the primary feed temperature, the domestic hot water output temperature, the primary return on domestic hot water, the domestic hot water flow going to taps, the flow rate on the primary side, the valve position for domestic hot water, and the total amount of water drawn through this heat interface unit since it was turned on. We have an indication of whether the room stat is calling and whether the central heating pump is running, the central heating output temperature, the central heating primary return temperature, the flow rate on the primary, and the valve position. So what we can see here is there is at the moment some fairly low load going on the central heating side of this particular unit. If we scroll down, we will see where our 5 warnings came from. They would be these 5 heat interface units where the central heating pressure has dropped below 1.5 bar. We can also see instantly that there are only 2 units currently running central heating. And there are no other alarms or warnings on the system at all. Now we can further drill down into information. So the central heating output here has a link to a further historical graph. This graph is showing us what the central heating has been doing in this property. We have the return temperature limit and the central heating maximum supply temperature. We have the supply off the heat network, the central heating being fed out to properties, the return temperatures, and we have the flow on the heat network. Now if we zoom in, it allows us to also see we have whether the central heating thermostat is cooling. Now what we can see here is a system where the central heating return temperature is hitting the return limit, while the output temperature isn't reaching the target temperature. What this tells us is the radiator system on this particular property isn't very well balanced. If it was so, the return temperatures from the central heating wouldn't be reaching their limits. So we can drill down into the central heating performance over time and figure out which systems need attention on the balancing on the radiators. Okay, now returning to our main screens, if we now have a look at how we may change the settings on individual HIUs remotely. So let us have a look at, say, this second unit down. So second unit at the moment has a domestic hot water set point of 53. Now let's say we want to change that to 51 degrees C. We can do that through the engineer screen. So if we go to the engineer screen, we have a list. Right, let's zoom that in a bit. We have a list of the HIUs here that we can select individually. And if I select that second one with a 53 degrees set point, I wish to change that set point to 51 degrees C. What we will see here is the 53 should be fed back as 51. There we go. So that's us changing the set point. We can change any of the settings on the HIU, this method, and we can also change the settings on the fly automatically. So we can build things like keep warm mode, Legionella mode, central heating run into some more advanced control strategies. The engineer screen also gives us links to individual detailed graphs for the individual HIU, commissioning sheets, and it gives us just a visual indication of what's going on each of the different variables. Okay then, so in summary, what this system has allowed us to do is to guarantee everything across the entire development is set up exactly as required. It allows us to check everything is performing as required. It allows us to spot any mistakes with performance or with settings before they become an issue to occupants, and it allows us to track the performance of the system on the return temperatures. You can find out more information about the Node-HIU control system on our wiki site at heatweb.co.uk/W. Thank you very much for listening.